5.4 mid-segment theorem. That's the only theorem in the section, and it's right here, but I'm going to show it in GeoGebra first. Um, a mid-segment is basically if I connect two midpoints. Okay, so when I connect these two midpoints, there's some interesting things that happen. Notice as I move this point around, doesn't matter if I have an equilateral triangle, obtuse triangle. Okay, it's kind of hard to see, but I can move these points around. There's something that's always true. Um, this segment DE is always parallel to AC, and it happens that this length is half as long as this length. So now, I'm going to skip this thing, but this is the kind of key here that you have the mid segment is parallel to the side, and then it's half as long as the side. So knowing that, this question actually comes really easy. Find UW and VW, they're the mid segments of this triangle. Find their lengths. Well, if this is 12, okay, if that's 12, the mid segment's half as long, 6. Well, if this is 8, well, the side has to be twice as long, 16. And there you have it. In this next example, we're going to be plotting the midpoints. So if I go to 1, 5, and plot the point S, and go to 3, 3, and plot the point T, and go to 4, 6, and plot the point V. Now I'm going to try to find the segments. So these are the mid segments, and I'm going to try to use a couple different colors here. If this is my mid segment, I know my side is going to be parallel to it. This is a midpoint on the side, and it's got to be parallel to this. So I know lines that are parallel have the same slope. Okay, so you need to use that information. Now I'm going to try to go through this problem slow because it's the one that a lot of people struggle with. This is a midpoint. So one of my sides goes through here. And this is, it's connecting two sides. My other side has to be over here. If I use the slope of this line as 1, 4, I can go, or excuse me, 4, no, not even 4, 3, 1, right? I'm going to use that to draw in my line here. So I'm going to go up 3 over 1, and now I'm getting a parallel line to this one. So I went up 3 over 1 from the midpoint, right? That's the midpoint. Now, to make that the midpoint, I have to have it in the middle. So I went up 3 over 1. I actually am going to go down 3, backwards 1, to find the rest of the side. This is one complete side. Now, I know this is the midpoint of the other side, and from here, I can, I could look at the slope of this line is up 1 over 3. Well, if I go up 1 over 3, they're going to be parallel, but I want to keep this in the middle, so I got to go up 1 over 3 again. Okay, my last mid-segment's here, a slope of -1, so down 2 over 2, down 2 over 2. So I'm going to do the same thing. I'm going to go down 2 over 2, down 2 over 2, and now have my triangle drawn in around my mid segments. So what are the coordinates of the vertices of the triangle? They would be over 2, up 8, over 0, up 2, and over 6, up 4. Those would be my coordinates of my vertices of the triangle. So kind of a fun problem. Makes you think. Now the last question here. RS, ST, and RT are mid segments in triangle XYZ. So these are midpoints. Find the perimeter of this triangle. Well, how does the mid segment relate to this segment? Well, if this is 6, this segment is going to be twice that. 12. This segment is going to be twice. So XY is going to be twice TS. So this is 14. And this is twice this segment. So this is 10. So 14 and 10 and 12 make 36 units. Okay, notice if I just found the perimeter of this triangle, 6 and 5 is 11, 18. If I doubled that 18, I'd have 36 units as well. Be an alternative way. Here's your homework assignment. A lot of people don't like 28 and 29 because they think they're proofs. They're not. They're just giving you information. Just because they give you information doesn't mean it's a proof. But I'll see you in class and I can answer those questions then.